Good morning, good afternoon, and good evening. I have this LED bulb that was damaged, and I opened it, inspected it, and there was a dark spot on this LED here. I actually took a picture of that, and I'll put it here somewhere so you can see it. Now what I did was I had uh, 9-volt LEDs from another bulb that I had that was damaged previously, and I recovered the LEDs from it. So I replaced it here to confirm that that's all that was wrong with this. And so now this actually works. But my experience with replacing just a single LED is that a few weeks later or a month later, then another LED blows up. And then you end up having to replace and replace constantly. So in this video, I'm going to try to replace all of the LEDs with brand new LEDs. And my hope is that by doing that, this LED will be almost like brand new. One other thing I'd like to mention is that I made a modification to the board of this LED based on a video that I saw on a channel called bigclive.com. In that video, he shows how to extend the life of LED bulbs by reducing the current that the bulb uses, so the power. And so even though in his video, all the electronics were embedded into this part of the LED, whereas in my bulb, it's in a separate board. And the components, the main component I see is different from the one on his video. But I was able to figure it out, and so I removed one of the resistors from this board and cut the power basically in half in the hopes that this will extend the life of the new LED that I'm going to put, and hopefully this bulb will last many, many years longer. So the main chip of the bulb is a GP9127, as you can see here. And so I took out the data sheet, and I determined that these two resistors, well, it was two, this one here, 4R99, and there was another one here, 4R99 as well, and they go to these pins here, which according to the data sheet are the current sense pins. And so just like the video from bigclive.com, I removed one of the resistors here, so basically the total resistance here doubles because these resistors are in parallel. So now the total resistance becomes about 5 ohms, and that reduces the power by half, and hopefully will extend the life of the LEDs. Anyway, I'll put a link to the bigclive.com video that explains all this in the description of this video. So just a quick demo to show that the bulb actually works. I'm hooking it through my series lamp here. There we go. All the lights, the bulb, the LEDs are lit. Now when I replaced this blown LED with one of the spare ones that I had, I basically came with the hot air from the bottom, and I had to wait like a minute or two, and then I was able to remove the LED and put the new one in. But I've recently acquired this hot plate that claims it heats up to 260 degrees, and supposedly I can just put this plate, which is basically aluminum based, put it on top, and it'll heat it enough for me to be able to remove the LEDs and put the new ones in their place. So I'm not sure if this works well. I'm going to be testing it for the first time right now, and so this can go terribly wrong, but Let's see how well it goes. Now, before I start heating the hot plate, I bought 9-volt LEDs, warm white, which is what this bulb uses. I'm going to take out 6 of them and test them with my bench power supply to make sure they work, and then we will proceed. They come in a reel like this. So here are the 6 new LEDs, just to show you quickly how I test them. Minus, plus, worse, 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 good, good, good. So all 6 are good. I had the power supply set to 8.8 volts, and I limited the current to 40 milliamps actually, because these are going to be running probably around 50 milliamps with the modification I made to the circuit. So the plan is basically to plug the hot plate into power, wait for it to reach the temperature so that I can remove the existing LEDs and then replace them with the 6 new LEDs here. Now they claim that the hot plate reaches 260 degrees, but I have a thermal camera, so I'm going to monitor the temperature to see what it peaks at. Alright, I've had the thing plugged in for a while, so it's already getting hot. Let me switch to the other view, see if it works well. Okay. Okay. How can I read temperature? 182. 184 pH. Looks like it reached 182 according to my thermal camera. Anyway, okay, so let's proceed. Let me see if I can pluck out. Yeah, they're coming out easily. 2, 3, 4, 5, 6. Let me move it a bit closer to the middle of the screen. Oh, this is really hot. It's ruining my pad. Let me see if I can lift it. Alright, hopefully this is better. Alright, let me add a tiny bit of solder where it's needed. With melt solder. Yeah, it actually melts solder. I put a red dot everywhere where the positive end should be. Let's begin. One, two, three, 4. Let me just do this. Okay. My piece of noise. Okay. No, the last one. I'm gonna disconnect it from the power. So it should start cooling down. Should I slide it off the heat pad so it cools faster? Let me see if I can do it without disturbing the LEDs too much. Yeah, I got it. So put it right here. Alright, I'm gonna let this cool down and we'll come back to it. Alright, so lesson learned. I would not put the hot plate directly on my mat next time. I have some permanent mark here. I would put it on this piece like I did eventually. Anyway, so before I go plugging this in and testing with the AC, I'm going to use my bench power supply again to check the individual LEDs. Like I said, I had a red dot where the positive goes, so I'm just going to go ahead and let me shift this. It's a bit hot still in the middle of the mat, so I'll work here. Okay, so let me test these. This is my power supply. Again, 8.8 volts with 40 milliamps, just like before. Now the plus is always going to be on the right side. Let's see how well we did. Yeah, that's good. That's good. 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 Last one. I'm actually blind, but let me see. Well, everything controls are good. So all 6 LEDs light up properly. Now the next step is going to be testing it with the board and then finally assembling it. Alright, so let's plug it in and see if we have light. And success. Very good. So now I'm going to put it back together and we'll come back for a final test. Alright, so it's assembled and we're going to do a final test. Here we go. I don't have the proper socket for it, so here we go. All good. Now the only thing left for me to do, I'm going to add some silicone inside here, followed by installing the lid. But this has been repaired, and so I hope you enjoyed this video and see you on the next one. Bye bye.